A uniform electric field E is created between two parallel charged plates as shown in the figure. An electron enters the field symmetrically between the plates with speed v0. The length of each plate is L. Find the angle of deviation of the path of the electron as it comes out of the field. So basically what is happening here, let's understand the situation. Okay, so here what we have is we have a particle. Which particle? We have an electron. So our electron is entering here, okay, in this direction with velocity v0, right? And these are the two plates, okay, any conducting plates, okay, having some charge positive and here negative. So what will be the direction of electric field? It will be downward here, radially away from positive charge and towards the negative charge, right? Because of this electric field, okay, so when it is traveling from here to here, it will not experience any force, right? But moment it enters this field, it will experience a force. What kind of force? Electric force. And what's the value of that electric force? F equals to QE. We will go into that. But let's understand the situation. What if there was no this conductors? There was no conductor here. If there was no conductor, this electron was supposed to go in this direction, right? Straight away, horizontal direction along x-axis. But because of this force which is experienced by the electron due to this electric field, it will, instead of going straight, it will go slightly upward. So it has a y component also. Along with x component, it will have a y component also. Let's figure out what is the y component. So what's the velocity along y-axis? Velocity along y-axis will be, we will find it, right? So that we will find, that will help us to understand this angle theta. So first of all, let's see what is the force experienced by this electron. So we know that the force is nothing but mass times acceleration. And this force is nothing but our electric force, which is Q into E. Let me repeat again. The electric force experienced by the electron will be QE, and because of this force, there will be mass times acceleration. Okay. What is mass? Mass of the electron is ME, correct? So acceleration produced in the electron will be QE by ME. This is the acceleration, right? And we know from equations of motion. So from equations of motion, which equation? Let's see. V equals to Vy equals to U, okay, Y plus A T, correct? Now be very careful, this acceleration is along y-axis, no acceleration along x-axis because there is no other force, right? So I am writing here Ay and this is our acceleration Ay only, okay? From equation 1 we will get acceleration along y-axis. What is our initial velocity along y-axis? 0, right? Because the electron was projected along x-axis. So there is no y component. So Vy will be equals to Ay into T, correct? And what is Ay? We just now found Q. Q is nothing but E, charge of electron, up E upon mass of electron into time T. That's our Vy. That is our equation number 2. Now we know that how much time it will take for the electron to go between these plates, okay, which is from this point to this point, okay. How much time it will take? Time is equals to distance upon speed, right? L upon v0, initial velocity with which it is projected. So this is our equation number 3. Let's substitute here. So this Vy will be equals to how much? E by ME, and time is how much? Length upon speed v0. This is our equation number 4, correct? Now this is our velocity Vy, okay? What's our velocity along x-axis? So velocity along x-axis is v0, Vx is v0, okay? So theta we can find at any point. Theta is nothing but Vx and Vy. This is Vy. So theta, tan theta will be the ratio of both, that we know from projectile motion also, last year 11th standard. So this tan theta is nothing but Vy upon Vx, correct? The ratio of velocity along y-axis and x-axis. So when you divide both, it will, what is Vx? Vx is v0. So this expression will take the form EEL upon what it is? M v0 square. Why v0 square? Because Vx is also v0. So theta, the deviation will be nothing but tan, taking on the other side tan inverse EEL upon MV0 square. Okay, this is our theta. Done.